was. So 43, as scientists, you're going to have to do this stuff the whole time with what we do today. Scientists claims that the mean incubation period for swan eggs is less than 40 days. First thing every single time, H-O, H-A. So this scientist says the incubation period is less than 40 days. Is that going to be your H-O or H-A? H-A. We use mu, P, sigma,
Mu.
elephant, what?
Mu.
Make sure you know what the elephant symbol is. It's on the test. So mu, what did they say? The scientist said what? Less than 40. Make sure you tell that that's the claim. We're going to put all this stuff together today, and you're going to have to do all of this along with all the rest of the stuff that we're going to talk about. What's our HO going to be then? Greater than or equal to 40. Part A says if you reject the null, you need to get out your little packet. And we're going to be on, I think I got the wrong packet. Get out the packet. You're going to look at this. We're going to use this a whole bunch today. First thing you look at was your claim, your HO or your HA? HA. So we look at this column. And the first one says you're going to reject it. So if we reject it, what are we going to say? There is enough evidence to support the claim that what? Mean period is less than 40.
Well, and the problem, it says, for 43 to 48, it says reject the null hypothesis. Are we actually rejecting the claim?
No. Every time you're basing everything off of the null.
But how you word it is based off the claim.
No, what? Sort of. Because you got to know which one of these two is the claim.
Yeah.
But whenever you're doing one of these hypothesis tests, everything is based off the fact that we're saying that we think that the mean period is 40. Whatever this null hypothesis says, we're taking that as truth when we start the problem, every single time. Part B, if we fail to reject the null. So again, the HA was the claim. So we look here, but we fail to reject the null. What's it going to say? It's this box right here. There is not enough evidence to support the claim. Starting to write like Brian. That mean period is less than 40 days. I promised Riley last time I wouldn't start getting lazy and not writing it out, so I'm going to continue. Try to keep up on my promise. Next question.
Good.
That's it. Now, with what we do today, and I'm going to give you I hate this word, but I'll say it once, sort of a rubric. When you interpret this stuff, and it's not really a rubric, but it's sort of. It's gonna have 3 parts. Just to try to make it easy on you. I'm gonna tell you what to write in the first part, what to write in the second part, what to write in the third part, and you do that every single time. Alright? So a lot of times all these interpretations will look basically the same. Daniel, that help?
Yeah. Section
7.2, and I went back through because it is the weekend, so I thought, all right, I'll try to be nice one time. Don't ever ask me to be nice again. And I separated this section into 2 parts instead of just having 1 part. So, hypothesis testing for large samples with the mean. So we're using mu with large samples. What do we consider a large sample? That might be the ugliest mean or the ugliest mu I've ever made in my life. So you guys can make fun of it now. Greater than 30. Large samples greater than 30. All right. All we're going to do today, we're going to find and use p-values. So we're not actually going to do the rejection regions today. We'll do that next class. So we're separating them so that you can understand one before we go on to the other. When we get to the rejection regions, I'm telling you that we probably never ever will use the p-values again because I don't like them. No other reason, Gage, just I don't like them, so we're going to use the rejection region. But I'm going to show you both. P-values. Key things here, when you're using p-values, we wrote these 2 down last time, but very, very important. If p is less than or equal to alpha, you reject the null. If p is greater than alpha, you fail to reject the null. Here in a second, the p-value, what we're going to learn about the p-value is the p-value is the area under the graph. All right? So when we graph it and we shade it, left-tailed, right-tailed, two-tailed, that's going to be our p-value. The area is the p-value. As we've been doing this all year long, when we draw this, our little graph here, we know the mean's right there in the middle and we have this part shaded. We said that that's the area. It's also the probability. It's the same thing. So that's why it's called a p-value, because it's the probability that it falls in that region. So we're going to find the p-value. I'm going to show you how to find the p-value longhand, and I'm going to show you on the calculator also how to find the p-value. And you're just going to compare the p-value to whatever alpha is. They're going to tell you alpha. Normally it's going to be 10%, 5%, or 1%. And you're probably going to see me draw this a bunch. I'll do something like this just because I know that my good friend Ben remembers back to 2nd grade, and he has fond memories of Mrs. Smith and his 2nd grade teacher saying, "Put the alligator mouth in the little circle. Which way should it be pointing?" Right? So you'll see me draw that, and we'll put the alligator mouth in here, less than, greater than, one or the other.
I don't even know who Mrs. Smith is.
They all look the same.
Yeah, I think they do.
They all look the same.
Yeah, they all were like super tall, skinny, and had long, dark hair.
It wasn't that.
Hey, Miss Herman.
In second grade, I had Miss Lawson.
Second grade,
I
Mr.
remember
Hose.
Lawson too. and
Mr.
yeah, it
Hose
was
was
like-
good.
What did that elephant get again?
Do you remember like her husband's
Dude,
walk
I
that like
wanted to
second
hear
grade
that.
senior and doll?
His dad
That
was
was
a
the first day we learned it. I didn't know it was a thing.
I remember old Maryland.
His dad was.
I actually believe.
Are you guys messing with Gage?
Yeah.
Yes,
No, he leaves
asked
out, he
me
goes,
about
"We're
the
being
elephant."
serious about the elephant. He leaves
I
out,
wasn't here
"What's
that
the
one
elephant?"
day,
He was like,
so I didn't know if that
didn't learn it or not. He's like, dude, I wasn't here last week.
There's no, Gage, there is no elephant symbol.
I know that now.
All right.
It's like being-
Good job.
You just got laughed at.
Sorry, Gage, I didn't mean to let him make fun of me.
You should have told me you were joking.
And
he did,
It's
he was
pretty
laughing.
obvious. It's alright.
So on this, we're gonna do just a couple examples here real quick. The p-value for a hypothesis test is 0.0237. Again, we're gonna actually find the p-value here in a little while, but now they're telling it to you. If your level of significance, your alpha is 0.05. So all we're gonna do is we're gonna look at 0.0237. Have our little circle there. 0.05 on this side. Which symbol goes in here? Less than or greater than? Less than. So the p-value is less than alpha, so that tells us to reject the null. That's all we're doing with this part. That's the first part of it. Actually, that's like the next to last part of it, because that by the time we get done, that's going to be towards the end of the entire problem, because you're going to have to write the null, alternative, all that stuff, find the p-value, then decide whether to reject or fail to reject, then interpret. Next one, 0.01. So if I do the same thing here, I do 0.0237, 0.01. What symbol goes in there this time? Greater than. So what's that tell us to do?
Fail.
Fail to reject the null. When we get to a test, that right there is going to be a point on a problem, all right? So each of these problems on a test are going to be worth like 7 or 8 points, because I'm going to say, write the null hypothesis, write the alternative hypothesis, tell which one's the claim, find the z-score, decide whether to reject or fail to reject, then do the interpretation, all right?
Did you say all of that's gonna, like, it's gonna ask us each one of those?
I might do that on a couple of tests. You know, I might put like part A, writing on part B. But then there might be another problem like out of the book where it just gives you the problem and says do all this stuff, and you got to remember to do the whole entire problem. After you determine the hypothesis test standardized test statistic, which is the z-score, we're going to talk about that here in a second. Then you do one of the following. And don't write this down. Sorry, I should have said that earlier. So what you're going to do, you're going to find the z-score, and we're going to talk about that here in a second. You're going to decide whether it's left-tailed, right-tailed, or two-tailed. We talked about that last time, correct? So if it's left-tailed, remember, for any of these, you look at your HA. If it's left-tailed, the HA has the less than symbol in it. If it's right-tailed, it has the greater than symbol in it. If it's two-tailed, it has the not equal to symbol in it. The one thing you got to remember is on this last one, when it's two-tailed, that means you're going to have two sections here. All right? So when you find your p-value is the area in those two sections. Well, what you have to do is you have to find the area of one of the sections and then multiply it by 2 to get the total area. That's going to be your p-value. For the left tail and the right tail, you just find the area, and again, touch your paper again. To find the area, we're going to use this chart. All right, so if I wanted to find the area for a z-score of negative 3.09, I look down at negative 3.0, go over to 9, that's the area right there. We've done that several times. Put it up here too quick. Find the p-value for a left-tailed hypothesis test with a test statistic of negative 2.23. Let's go back one. And then decide whether to reject or fail to reject if your level of significance is 0.01. So get out your charts, help me out. We know our z-score is negative 2.23. We want to know, I'm looking at this my little graph here, means right in the middle, negative 2.23 somewhere over here. We want to know this area. So on your chart, look up negative 2.2 and then go over to 3, and what's it tell us?
0.0129.
0.0129. You guys think Ben just remembered that from what I had pulled up there? Did he actually find it? He found it, all right. That's our p-score, or our p-value. What's our level of significance this time? 0.01. What symbol goes in here? Less than or greater than? Greater than. So what's that tell us? Fail to reject the null. We fail to reject the null.
That's the first one.
Looks like we did it all right. Next one, find the p-value for a two-tailed hypothesis test. Now, me and the book sort of disagree on this. Two-tailed, and our z-score is 2.14. So that means we're going to be out here somewhere at 2.14. What's the other end going to be?
Negative 2.1.
Negative 2.14. And what do we know about these two areas? They say look up the 2.14, which means you got to flip to the second page. Why? Can't we just find this area and it's going to be the same? So look up negative 2.14, find the area for it. I bet it starts with point something.
0.0162.
162, everybody agree with that?
Yep.
Now that's the area in this tail. We got a two-tailed, so we want what?
Times 2.
Both of them. So we got to take this times 2. Somebody do that for us on your calculator. I bet it starts with the point again.
0.324 is, I think.
324?
0.324.
There you go.
That's what it is.
That's our p-value. Do our little alligator mouth hole there, and 0.05. This is less than, so what's that tell us?
Reject.
Reject the null.
Not too
So we did all that. Now notice, they found 2.14, and if you were finding this area, your chart doesn't tell you that area. Your chart tells you the area from here over, so they had to subtract that from 1, and guess what they get? Why do all that work? I don't know. Z-test for a mean. Don't write any of this down. Let me look at it first. This is stuff hopefully you remember. Can be used if the population is normal and sigma is known. Are we going to know sigma most of the time? No. Most of the time we're going to go by the fact that our sample is what?
At least 30.
30 or more. All right, so that's most of the time. This formula down here, this is the formula, and we've talked about this formula that you're going to have to use for Z, but on the next slide, there's a better way that the formula is written out instead of just in words. And so that's probably going to be easier. This is how we're going to find the Z. They've been telling us the Z score up till now. Now we got to find it ourselves. All right, and this next part, this I would write down. That formula right there, important, very, very important. We've written it down a few times. It's the exact same as stuff we've done in the past. We're just finding that Z-score. bottom formula down there, that's just the bottom of it. That's telling you, hey, this is the standard error, which we wrote down last chapter. You don't really need it again. As long as you remember that that bottom part is the standard error. X bar. X bar comes from where?
Same.
You're saying. Mu comes from the population, which in this case is going to be your claim. All right, what you're actually writing in your HO and your HA. Sigma is the standard deviation. Are we normally going to know what sigma is? So in place of sigma, you might want to put this in there. Use S. You're going to know the sample standard deviation, but you're not going to know the population standard deviation. All right, there's going to be like 7 steps to this. Number 1 is that. Number 2, that. Number 3, find this. Number 4, use the table. You're going to use the table to find the area. Or actually to find the z-score. You're using the area to find that. You knew I was coming before you did. You know that's 2 strikes today, right?
Yeah,
You know what happens on 3,
I'm
right?
hearing you.
You want us to write this down?
What? Yeah, I would write down, this is what we're going to do. This is the steps you're going to do for all these problems. I put over there on the side, on the right, that's the part I would write down, not the whole sentences and everything. I tried to shorten it up for you over on the side, so you wouldn't have to write so much. Unless your name's Daniel, then you don't have to write anything. Sleep. Go to sleep. I won't yell at you for going to sleep.
Can't be on your phone if you're sleeping.
But then you miss out on things like the elephants.
Yeah, elephants, don't wanna miss that.
I could use that.
You're gonna use that again.
You guys are never gonna forget
Wipe
that
my
one.
hand on Sean's hoodie.
You at least use hand sanitizer.
Pretty smart sometimes.
Or sometimes. Jordan was taking pictures of you.
Last night?
Yeah.
Was he? Was he standing behind me with my butt hanging out or something while I was looking in the hole?
No.
I don't think I was doing anything else.
I'm sorry.
They were working underneath their house. And there was a hole for the crawl space, and I was laying with my head down in the hole because I wasn't crawling. That's their job to crawl underneath their house, not mine. I'm too old and out of shape for that.
Yeah.
Was he probably saying, lazy won't go down in the hole? I bet, wasn't
I mean, Jordan said a lot, eh? He talked a lot.
And I told him, I'm not going down that hole. I'll pass you guys down all the stuff you want. No, I'm not going down that hole.
Really showed up.
Yeah, I could have, because you know if it was just him and Vinny there, who's climbing out in and out of that hole to go up and get something that they forgot to take down with them all the time, so he better think that and think, you know what, I was pretty happy that he was there. So the first thing, again, state the null alternative hypothesis, figure out what your alpha is, find the z-score. Once you find the z-score, you're going to use the table to find the area. That area is going to be your p-value, right? Maybe we should write that. That area is the p-value. Then 3 more steps. Sorry, it's not on there. On this first one, on step 5, just put p-value. You don't have to write all this stuff down. You gotta decide which tail it is. Maybe write that. Which tail? Left, right, 2. Then number 6, decide whether to reject or fail to reject the null. And then the last one I moved to the next slide because it's the interpretation. And very important that you write down how to interpret it. It's going to have 3 parts, and we just do those same 3 parts over and over and over again. Using the p-value is not difficult. I just don't like it. That's the only reason that next class we're going to learn the rejection region is, and then you're going to try to stay with the rejection region for the rest of the year. That way we only got to learn one thing instead of dealing with 2 separate things over and over again. I'll let them that way for you. I pick my nose and stuff all the time and scratch my butt.
I'm watching you, but still. That's
The way
but
he
you're
really-
doing it.
You watch me do what?
But we've seen you pick your nose and scratch your butt.
Have you seen me pick my
You literally,
nose?
no, it was just the way, like, you were, like, in scratch your butt, and you actually scratched your butt.
But that's you doing. That's
Scratch
you,
my butt, you might have seen me do that.
That's you doing it to yourself, though. You just touched my body tissue. That was gross.
They're missing out on the funky class today.
Yeah, you know Phoenix ain't gonna watch.
We should have said hello.
Number 7, to do the interpretation. I highly suggest you write down these 3 things for your interpretation. The 7th step. This is what we're going to write each time. And I'm going to show you how to do it as we go. First part of the sentence is going to talk about the level of significance. Second part is going to be the sentence from this chart. And then the third part is going to tie it to the problem. So we're going to say something like, with a 5% level of significance, there is enough evidence to reject the claim that Jackie has seen Ebersole pick his nose during class. You've never seen me pick my nose.
I don't think I have. I don't recall.
I mean,
Of course, you guys would say you haven't seen it.
We're not like not siding with you.
The only
I just
time that
think you're just
you might have seen me pick my nose is when I said something like, I don't know, somebody was probably sharing something with somebody else, and I said, yeah, I just seen him picking his nose a second ago. Yeah, just had his hand in that bag, and you stuck your hand in there.
Well, yeah, he's done that. But he hasn't like been over there like.
Wandering around.
You may have like scratched her.
You guys also don't-
Going like this and watching around and balling it up.
Now I've seen you do that before.
Yeah.
Green papers.
What show was that on? Caddyshack or something? Is that what it was? Caddyshack. That's an old show.
I
You
ain't
guys.
seen the Caddyshack. I've seen that.
Have you seen Caddyshack? Wasn't that on there? The one.
Phoenix is the old movie guy.
On what?
They were betting on.
That
They
has
were
to be
betting on
old
if he was going to eat it or not. And
Say.
he was like looking around.
I do remember that.
What movie?
Caddyshack.
Doesn't have Bill Murray?
I've probably seen it, but.
As a matter of fact, who was it, Tony Romo, just put out a commercial. You seen the commercial with Tony Romo?
Who's Tony Romo?
He was a quarterback. If you see a commercial with Tony Romo, I dislike Tony Romo, but it made me sort of like him.
You just said Tony Romo.
Yeah, horrible guy.
He put out a commercial where he's chopping the heads off of flowers with a gardening tool, and that's what Bill Murray does in the movie. Rising star from nowhere, Alabama, or something, like all going crazy.
Sounds wild, I ain't seen that one yet. Hoping it comes back up.
Maybe. I'm sure about the story of Mr. Hoffman cutting off the moose's head.
All right, what? An example here. We got a couple examples and we'll be done. In an advertisement, a pizza shop claims that its mean delivery time is less than 30 minutes. A random selection of 36 delivery times has a sample mean of 28.5 minutes and a standard deviation of 3.5 minutes. Is there enough evidence to support the claim at a level significance of 0.01? Use a p-value. First thing I usually do when I'm doing these problems, I write down all the stuff that I need to know. So like n is 36, right? And our sample mean, which is our x bar, is 28.5. Our sample standard deviation is 3.5. And our level significance is 0.01, so 1% level significance. I think I've gotten everything. Once we have all that, we're going to go through those steps. First step, write your HO and your HA. And I'm probably going to run out of space here, so I'm going to have to do it on the side or somewhere else. So this time, we look back at it and it says the pizza shop claims that the mean delivery time is less than 30 minutes. Is that going to be our HO or HA?
HA.
Which one? If it's less than 30 minutes, that's got to be your HA. What symbol are we using?
Mu.
Mu again, so mu is less than 30. That's our claim.
Means greater than or equal to.
Then our HA is mu is greater than or equal to 30. That's our first step, write our HO and HA. Second step is to find the alpha. We got it already, it's not hard to find, they tell it to us. 0.01. Third step, what did the third step say to do? Find the z-score. The z-score is that formula. I think it's x bar, is that right?
Yeah. X bar minus mu.
Have your calculators out so you can help me. Minus mu comes from the claim. All right, so 30. Sigma, we don't know sigma, but we do know S is 3.5, and then the square root of n was 36. And I would probably, what is the square root of 36? 6. I'd probably do that so that I don't have to mess with the square root button, if you can do it in your head. When you do this, subtract the top, hit equals, then hit divided by, and put parentheses around the 3.5 divided by 6, and then close the parentheses. What did it come out to be?
Negative 2.57.
Anybody else get that?
Yep.
That's not what you got?
Negative 2.59.
What'd you do?
Well, I mean,
Did you put parentheses and stuff?
yeah.
Did you run
I think it's negative 2.57. I think that's right.
Probably is.
Now, once we have our z, what did the next step say to do? Find the area, which is the p-value, right?
Yeah.
So you go to your chart, and what we're looking at is this area right here for negative 2.57. 0.0051.
Yeah.
Does everybody agree with that? Yes, no, maybe?
Yes.
0.0051. Now I'm running out of space over there, so I'm going to do it over here on the side. So now I do this. .0051 with our little alligator hole thing there. What's our alpha this time?
0.0.
So what symbol goes in there? Less than. What's that tell us? So we reject the null. Again,
It's a left tail.
on a test, that's point, that's a point. Finding this is a point, finding that would be a point.
What was that, 36.6?
Beside that, what was what?
No, I think.
Oh, did you type in 36.6? Is that what you did?
Yeah.
Yeah, it's just, I just did the square root of 36 and it was 6. I did it in my head instead of punching it in the calculator. So we do all that. Once we have that, we decide to reject the null. Next thing we do is we get out our little paper and you're going to look. We're going to look at this chart. Everybody understand all that so far, so I can erase this?
Yeah.
So I can write stuff down. We're going to look at this chart and we're going to write our interpretation. First thing you're going to write in your interpretation, the very first part is the level of significance. What was it? So with a 1% level of significance,
Why can't you just put it up?
with a 1% alpha, is that what you're saying?
Oh, yeah.
Yeah, because I don't know what the alpha is.
Okay.
That's the first part, with the 1% level of significance. The second part, and you don't number these, it's supposed to all be one sentence, I'm just trying to show you how it's separated. You look at your chart here, was our claim the HO or the HA? It was the HA, and did we reject it or fail to reject it?
Rejected.
We rejected it, so we're looking at this very top one right here. There is enough evidence to support the claim. Then the third part is just tying it back to the problem. What was the claim?
The mean delivery time is less than 30.
That the mean delivery, I should have wrote this with that other pen, I don't know why I'm writing it with the black pen, but mean delivery time is less than 30 minutes.
Why does that make it seem like it's a lot less writing even though it's more?
It's not really a whole lot, it seems like it is as I'm up here trying to say it all out 1,000 times.
It just looks like less, even though you're writing a whole extra sentence than what we were.
Yeah. Does everybody understand that?
You want us to write it out with numbers or just make it like that?
We mean write it out.
He
Oh,
said
no.
make it a sentence.
Just make it a sentence, so yeah, that, I was just trying to show you the three
Yeah.
parts. Every time you're gonna do those three parts. First one, level of significance, second one,
Do we have to,
from the chart,
is
third
that
one.
gonna be the, well, I know you're gonna grade like if the null and the ultimate are there, but do we, I'm assuming we don't really necessarily need to show over other than that? As long as we have what it is mainly asking for written down, we're good?
Yeah, I'm gonna look at the Z, so if you have the Z score in there somewhere, I'm gonna look at that. The null and alternative hypothesis, which one's the claim? The Z, probably, the little picture.
Oh, we have to do the pictures?
Yep.
Oh.
I'm gonna look at that, That way I can tell if you knew it was left-tailed, right-tailed, or two-tailed.
Right, left or right?
Yeah, maybe. We'll see.
Okay. That's why I did it on my homework, because I just wrote the word. I didn't write it.
I would rather you draw the picture, because then you can put the z-score right here. And especially when we get to the rejection regions, then yeah, you have to draw the picture, because I have to see where the rejection region is. This is gonna be the rejection region. Is it that hard?
Yeah.
You need Mackenzie to come back here and show you how to draw that little curve?
I mean, I can't do
I
it.
just don't know.
Am I gonna grade you on whether your curve looks good or not?
Yes. Yeah, those things, I don't know how he does them so well.
Yeah,
I always
I
make
can't.
mine lopsided, dude.
Oh, yeah, I can't.
It's
Like,
literally just,
Yes, I do that,
It's a
but then
hill.
this side is perfect, and then this side gets
It's a
like
line
too
up
long
there.
or something.
Yeah, but making both sides even is like.
Yeah, I look at
It
it
doesn't
for
have
too
to
long,
be
and then it looks
perfect.
weird, and then I don't like.
So this, Michael, to answer your question for everything,
Too steep.
1 point, 1 point, 1 point, 1 point, 1 point, 1 point, and probably 2 points on your interpretation. Alright, so this is all the stuff that you would need to show me. If you don't show me the work here, you just tell me Z is this. I'm not gonna throw a big fit about that as long as I know what Z is, but most everything else on here, you could, if we're doing p-value, you could draw the little alligator mouth and p, 0.0051 and 0.01 on the other side, and that would suffice for the picture. But when we do the rejection regions, you're gonna have to show me the picture. You think that the average franchise investment information shown in the graph is incorrect, so you randomly select 30 franchises from 30 franchises and determine the necessary investment for each. The sample mean, and I'm going to write all this stuff over here. So N is what this time? 30. The sample mean, which is our X bar, is 135,000. Big number. Standard deviation, that's our S, is 30,000. Good. Our alpha, our level of significance, 0.05. And mine's cut off. You can't see it over there. I think it says 143,000. The average investment's 143,206. 260, is that right?
Yes.
143,260. So we're trying to decide all that. This is where our claim is going to come from. They're saying that the average is that. We're saying that the average is maybe closer to this. All right, so I'm just going to do this one out. Our HO, HA, if they said it's this, is that going to be our HO or HA?
I thought it was our claim.
No, it's their claim. We're trying to decide. So that's our HO and it's the mu, right? So that should be our HO. And then our HA is not equal to, which one of those was the claim? Which one? HO.
they're claiming that it's equal to that.
So they're claiming that.
Says in your notes.
Does it?
Yeah.
Let me go back and I should probably go back and read the problem.
But
Why?
HO is what the company's claiming.
So the company claimed that, so maybe there's one in there, maybe I didn't read it right.
Dang it.
I don't know, we'll see. If my pen ever works.
I've been reading his notes.
We find our z-score just by punching in this stuff, get negative 1.51. So if I'm on my little graph, first of all, is this left-tailed, right-tailed, or two-tailed?
Two-tailed.
Two-tailed. So we got this, we got this. To find our p-value, somebody help me out on the chart. Let's do this real quick. Negative 1.51. What's the area for negative 1.51?
0.0655, is
Anybody else see that? 0.655?
Yeah.
Now, if it's 0.655, you multiply it by 2, that's going to give you your p-value. So if we take that times 2, we get 0, 1, 12.1210. Is that right? That's going to be our p-value is 0.1210, hopefully. No, 1230, 310. All right. So multiplied wrong. Forgot to carry my 1, didn't I? That's our p-value. Then we compare that to our alpha. Our alpha was 0.05. That's greater than that. So if our p-value is greater than the 0.05, that tells us to do what?
Fail.
Fail to reject the null. And when we write it out at a 5% level of significance, that's the first part. We go to our chart. There's not sufficient evidence to conclude the mean franchise investment is different from 143,260. So I think I was right on my notes. I think this one is actually the claim because we're making the claim. And Michael was right. That's what the problem said is
Okay.
treat it like you're making the claim this time. This is how you do it how you find the how you find the p-value on your calculator. And we're going to do one problem using our calculator, so get your calculator out and then we'll be done. Unless Zoe annoys me some more, then we're going to do more. Tell me, Sean, what was Jordan saying about me?
He didn't say much.
You just said he said a whole bunch of stuff.
He always says a whole bunch of stuff.
Nothing that mattered.
No.
Or he's just trying to protect your feelings.
Just show me, take pictures of me laying on the ground playing with the dog. The dog loves me because it stayed with me for the first week or 2.
I didn't even get to see the dog.
You need to send her over to my house. She's looking strong. Back her up.
I mean, Ruby's lived long enough, I'm sure.
Ruby wouldn't. I was afraid to pet her. She acted like every time I went to pet her or something hurt. So I thought, well, maybe I'd rather not pet her anymore. So on your calculator, you go to stat, test. I think z-test is the very top thing. Not z-interval, not all the other stuff that we've done up till this point. The z-test, I think it's the very top thing. If you're putting data into a list, then use the data. If you're putting it into, or if you're just putting in statistics, the mu and all that stuff, then you go to stats. Type in the 4 things, those are the 4 things, mu, sigma, x bar, n that we need. Then it's got then you got to look at your HA and decide, are we doing a two-tailed, left-tailed or a right-tailed? That's what it's asking you there, and you got to pick one of those. Then you hit calculate. So we're going to do, I can't remember if it's the first problem that we did or the last problem, just to try to see here, it's the last one. So we're going to type in all that stuff just so we can see what the p-value actually should have been. We go to stat, go over to test, z-test. This time we're putting in stats. For our mu, what's our mu this time? What did we take when
143.
143,260. 143,260. What's our sigma this time?
30,000. We have to use the S.
All right, we have to use the S, so we just put in 30,000 because we don't actually know sigma. What's our X bar this time? What's our mean of our sample that we took? 135,000. Put that in there. And what's our N this time? 30. Is it all right for our N to be 30?
Yeah.
As long as it's 30 or more, right?
Yeah.
Then you go down.
What about me?
Which one did we use? Is it two-tailed, left-tailed, or right-tailed?
It was two-tailed.
So it's two-tailed, so just put your cursor on two-tailed and hit enter, and it'll darken it. Then go down to calculate, hit enter. And you look down through there, it tells you the z-score. What's the z-score? Which negative 1.51, which we said, right?
Yeah.
What's the p-value? 0.1315. That doesn't sound like what we said. Is that what we said?
Yeah.
We said 131.
Except 131.
But we said 131. But that's 135, so you found that 132.
So this one's just a little higher than the other one was. And a lot of times when you're using the technology, it'll be a little more. If you've ever used the back of your book, sometimes you see in the parentheses, it'll say this answer, then right next to it, it'll have parentheses, tech, and they'll give an answer that's just a little different. That's why. Once we know that p-value, then we can set it up with our little things here, and it was 0.05, and this was greater than, comes out the same, then everything else is the same. So all this actually does for you, allows you to find the z-score and the p-value. Doesn't do all the other stuff for you. Handle that, Jack. That's the assignment, 3 through 16, 25 through 28, 29, and 31. The first bunch here, I think, is just asking you to do like, write the HOHA or something. I don't remember sure. Then the second bunch is saying, do you reject or fail to reject? And then these last two, you actually have to do the whole spiel on it.